Hello guys, in this video we are going to discuss the solution of the problem split the array. So let us look at the problem statement. The problem statement says given an array of integers, the task is to count the number of ways to split the given array element into two disjoint groups such that the XOR of elements of each group is equal. The answer could be very large, so print it by doing modulo with 10 to the power 9 plus 7. So for instance, if this is the array which is given to us, these are the groups or these are the ways by which we will be able to divide the array such that the XOR of these two groups are equal. So for instance, XOR of 1 and XOR of 2 and 3 are equal. Similarly for the rest of the cases. So there exist three such groups because of which we are returning 3. In case it is not possible to divide the array in such a way, then in such case we are returning 0. So that's the problem statement, folks. Now let us discuss the solution of this problem. So in order to understand the solution of this problem, let us say that there exists a way by which we will be able to partition the array into two groups such that XOR of group 1 is equals to XOR of group 2. In such condition, group 1 can be considered as consisting of some elements of the array. Let us say those elements are A0, A1, A2 and so on. Then G2 should contain all other elements of the array, the remaining elements of the array. Now, as we know, XOR of group 1 is equals to XOR of group 2. Then what does it simply mean? Well, it simply means that XOR of group 1 and group 2 should be equals to 0. And the reason why XOR of G1 and G2 is equals to 0 is because we know that XOR of same elements is 0. XOR of A and A is 0. Similarly, XOR of G1 and G2 will be 0 because G1 is equals to G2, or rather XOR of G1 is equals to XOR of G2. These results to A, then in such case A XOR A is 0, because of which XOR of G1 and G2 is equals to 0. So in order to solve this problem, all we have to do is we have to compute the XOR of all elements of the array. If XOR of all elements of the array is not equals to 0, then this simply means it is not possible to partition the array into two parts such that XOR of group 1 is equals to XOR of group 2, because of which in such cases we can just return 0. Otherwise, if XOR of all elements of the array is equals to 0, then in such case we need to count the number of groups. So let us count the number of groups. So in order to do so, let us take an example. So let us say the array which is given to us is this. As we can see, XOR of all elements of the array is equals to 0 in such case. So it is possible for us to form group over here. So it is possible for us to partition the elements into group. So let us do that. So these are the elements which we have, and let me write the same element over here. Now if one has to form a group, it can form a group with 2 or it can form a group with 3. Similarly, if 2 has to form a group, it can form group with either 1 or with 3. Similarly, if 3 has to form a group, then 3 can form a group with either 1 or 2. So in a sense, what I'm trying to say over here is, if n has to form a group, it can form group with all elements except itself, so n into n minus 1. And then this number has to be divided by 2. And the reason why we are dividing it by 2 is because 1 forms a group with 3, 3 also forms a group with 1. So we are counting same number twice, and since we are counting same number twice, in order to eliminate that, we are dividing it by 2. So the total number of groups which can be formed will be given by this equation. So the solution becomes very simple, and in order to solve this problem, all we have to do is compute the XOR of all elements. If XOR of all elements is not equals to 0, then in such case we will return 0. Otherwise, return n into n minus 1 by 2. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to count the number of groups and an array is given to us. So for this, XOR equals to 0, and then we are going to iterate on the elements of the array. So for element in ARR, and let us compute XOR. So XOR is equals to XOR of element, and then all we have to do is we have to check if XOR is not equals to 0, then in such case it is not possible to partition the array, because of which we are going to return 0. Otherwise we just have to return n into n-1 divided by 2. And since this value could be very large, so we need to return modulo operation. So this is what we are going to return. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. Over here we have a XOR and a mod. Then we are performing XOR of all elements of the array. If it is not equals to 0, then in such case we are returning 0. Otherwise we are computing n into n-1 by 2 modulo mod operation, and then we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. We have a XOR modulo. We are performing XOR of all elements of the array. If this XOR is equals to 0, then we are computing n into n-1 by 2 modulo mod. Otherwise, we are returning 0. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.